Okay, move me up there just so you know I exist. Okay, so yeah, statistics, just talking about the selling of that. So again, repeat myself, many of you may take two math classes, or you might not take the calculus, you might take the stats. I'll tell you right now, okay, I'll go back to my story. Lucky enough, although it was very terrifying, that about 6 years ago I was asked to teach the stats slash discrete class. One semester stats, the other one discrete, which we still have those awesome classes there. Really cool senior classes. But the stats was terrifying. It's like someone that's taught biology for 20 years, all of a sudden being asked, you have to teach physics next year. I don't know if you know anything about biology and physics, but there's not much correlation between the two classes, and the organization of it to teach quite different. Stats is like its own different world. It's not algebra based at all. Um, it's actually formula based. You have to know what formula to use, how to insert the numbers in the formula. But then the biggest thing is interpretation of the data. There's some writing, um, so that you know that you're interpreting the data correctly. So as far as stats is concerned, and what you're going to do when you walk out of here, you'll be surprised how many things require stats. You want to be a nurse? You got to take a stats class. You want business or marketing? Are you kidding me? You're going to take a stats class. And we're going to show you a stats video I found just watching casually TV at home that I think really hits home, like how important stats are and what it's all about. Hi, I just want to make sure I didn't hit the right or wrong thing there. One more thing before I get into this, and obviously what you're seeing here, hopefully you have a nice little calm beginning. Oh, mean, median, and mode, I did that in fourth grade. And that's actually true. You probably did it in some not too long ago, or a while ago, grade level, fourth, fifth, sixth grade. Just that is, simple terms there. But anyway, kind of blabbering. So yeah, stats are all over the place, and the majority of you, if not all, when you go to college, you probably end up taking a stats class, right? It's probably true, especially if you're in a higher level kind of math-based kind of what do you call it? The thing that you take in college, your degree, your the what's that called? Your major. That's what. Thank you. You didn't help, but I was just saying, major. Okay, so anyway, here's what stats is, and that's why we start Mickey Mouse. It's organization of data. That's really what it is. It's organizing data, collecting data, organizing it, so then we can make predictions. By the way, that's the name of our video, predictions by the numbers that we're watching on Wednesday. Okay, but one thing when you get a list of data, finding the mean, median, and mode. Very simple. Median is middle. That's it. That's all I ever, if I was a note taker, that's all I would write. It's the data right smack dab in the middle. This is all I'd write for mode. Mode is the most. Mode, most frequently occurring number. The number repeats itself. And then the only thing I'd write for mean, don't be crinkling those bottles. Who was that? Somebody new? Put that bottle on the ground. You've been canceled. All right, I heard that crinkle. Can't stand that. There, and then he puts it down and he crinkles it on purpose. Nice little kick in Mr. Samuelis's direction. Love it. All right, now those are the graphing calculator. Go ahead and get that out right now. I'm going to show you one little feature that you will not have to use ever again. It actually takes too long, but I do want to show. And I did spend a lot of time with my other hour to show this. And I guess I will go through it with you. Boy, this is going to be a stunning video. You're about to see a glorious math teacher type 24 numbers on a calculator. It's going to be great. Okay, and then I want you to open it up. And, oh, don't look at that. Clear. And then don't look at this. Stat, edit, don't look. I just want to delete. No, don't delete. Clear, Mr. Samuelis. Okay, then I'll show you something. All right, second quit. All right, go to this button, which is stat. Okay, now I like how this calculator works. It's in red. That's where it's located. Really helpful for the students here. And if you have a Casio, you're on your own. I have no idea how that thing works. I'm sorry, Texas Instruments has a monopoly on graphing calculators in schools. You can get that Casio, but you're on your own as far as how that works. Press enter, and then it's stat edit. That's what we hit first. We're in a list feature right now. How many people see this? L1, L2, L3. Anyone missing L1 or you don't have any names up there? Does anyone have any numbers in their list? Like you have numbers sitting in there already? Let's go ahead and do that real quick. Now I'm going to tell you a story about sad Mr. Samulus. Don't even put it on that. Just type random numbers. 6, 1. Just do it. 5. It's not even my list of numbers. I'm going to second quit. Get out. Just go to the main screen. Then I'm going to go back to stat and edit. And it's still there. I just wanted to tell you that there's an autosave. Once you type it in there, it stays. How many people have a calculator and actually playing along? You're supposed to have a calculator for this class, a grapher. Looking around, how many people do not? That does make me sad. All right? So we are supposed to have graphing calculators. You'll definitely be expected to have that next year. If you don't, all right? And that's basically it. You get students that just don't think they have to do things. Not good. Not good at all. Hey, here's Mr. Samulus in the 90s. This actually happened to him. And I think if I recall the story correctly, I had to shut down what I was doing because I didn't know how to get out of it, what I'm going to do next. Well, I don't want that list anymore. How do I get rid of it? Let's all do the same thing together. So go up to L1, the name, and the first natural thing Mr. Samuel thought was I want to delete that list because I want to get a new list there. Ready, set, go. Gone. L1 completely disappeared. All right. So did I really delete the list? Maybe, but now I don't have that L1 name up there anymore. And then I didn't know how to go further from this. And I had to say to my class, you know what? I got to go talk to someone that knows more about this than me. And I got to delay this till tomorrow. As a matter of fact, do this right now. Delete, 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 destroy them all. The reason I always go through this with students is this is a problem. This is something that people accidentally do. And then you need to know how to correct it. Okay? So now, hopefully all of those are you're following directions. You did this naughty thing, this thing that actually is a problem. And now we're going to go and reinsert those lists back. This will also help you to see where that name is right there. Whoops, I did that wrong. Second quit. So now I have to stat edit again and then see that my lists are all gone. Second L1. There is that name, and then watch what happens. Not only do I get the name L1 back, I did not even clear out that list. That list still exists there. Actually, go to the second position. Again, you have to be up here, and then reinsert L2. Reinsert L3. And just as I'm doing this, when you when I reset your memory on your calculator, these all come back empty. L1 through L6, all those names come back. So that's another way of doing it. I can go ahead and second mem. If I do a 712, reset my calculator, stat edit. That's another way of getting rid of that list. Now my list is gone. All right, so that's another way. But I'm just going to go ahead and type some numbers in again that I don't want. So now I have this list. How do I get rid of it? You don't hit delete, you hit clear. So go up to the name L1, hit clear and enter, not delete and enter. Now I keep the name L1, and now I have a clean list in order to type. Then here comes the stunning notes video. Mr. Samulus typing in random numbers, and I want you to do the same thing. Do not make a mistake in typing these in, and you should be faster than me because I have to use my mouse to do this. So we're putting this in L1, and we're going to put all, if you looked at that, this is a teacher's grades on a quiz kind of thing. 55. If you were in a stats class, a lot of times you do a lot of stuff for one list that is long and obnoxious. So we definitely use the graphing calculator a lot in this list feature, for sure. Okay. Keeping going, 90, you're going to want to do the same thing. 85, 85, 32, 68. This is a stunning YouTube video. The teacher reading off numbers. 78. And then come on over here. 85. I hope the dog didn't make any mistakes because I do want to use this to show you some information that this tells you when I hit a certain button. 95, 98, and 278s. And then notice that actually does tell me that L1 24. That means there's 24 numbers, right? That's the 24th number in this list. And then I stop. Okay, so here's what we want when we want to organize this data. One of the simplistic things to organize the data is put it in order. Are we sleeping back there? Or are we okay? All right, look awfully comfortable. All right, so here we go. And this is what I'm going to do. Exactly what this says right here. Calculator. Second, quit. Remember I told you when you quit and get out of there, that list stays. You know, it's auto save. And then this is what we're going to do. Stats. And this is what I want. I want to sort this from smallest to largest. So sort A is sort ascending. Sort D is descending. So I want to sort A. This has to be in the main screen. And I put my list in L1. You can make a list in L2. And we have two variable stats and when we do statistics. So we do an L1 list and an L2 list. And then we do some comparisons between those lists. That was a valid drinking of that water. Thanks for not crinkling. Well, that's a hard plastic bottle. So, all right, done. What's done? What happened? All right. Well, you got to go back to your list. Hit stat and then edit. Boom. And now you can see 32, 40, 55, 65, blah, 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 blah. Okay, there's a lot more that we do with statistics with lists of numbers. A lot more things. So for purposes of your tests, you know, and anything that you're going to do for homework, you don't really need to do this. This does take a long time to insert the numbers and so on and so forth. But I wanted to show you that this is a thing, that this can happen. We do actually sometimes do lists in that's coming up actually in CAT. We are going to put numbers in a list and do something with them in CAT Thursday, probably even Wednesday. Okay, so numbers in order, that's what I have. So take a minute to write those in order. And then you're going to use this list numerous times. So have the ability, so you don't have to keep rewriting this. Have the ability to just manipulate this a few times, but just write this list once. Don't hack it apart too much. So what we're going to do next is make a box and whisker. I'm going to show you how the graphing calculator. Oh, by the way, I was supposed to find mean, median, and mode, so I forgot to do that. I'll show you how the calculator can do that real fast. For mean, it's annoying. I would have to add all 24 of these numbers up and then divide by 24. All right, so, and you got to make sure you don't make a mistake. On a test, I won't have a list this large. It is annoying. The point of it is just to be able to do that. You know, so I think a list is probably going to be like no more than 10 numbers on a test. And then mode, we're going to have to actually find mode. And it looks like it's 78. Oh, this is bimodal. I have 78 3 times. I have 80, wrong. 85 is 4 times. So the mode is 85. Okay, so we could write that as you're writing this down here. I didn't say that in the other class. So 78 happens 3 times, 85 happens 4. All right, mean and median. We can find the median here coming up here, and we will. But for mean, I'll show you, since I put this on here, or I put it in the calculator, I'll show you that real quick. But I'm stalling for you guys to write this in order. Do make sure you have 24 numbers, double check yourself, and then we'll use this. That's the last time you have to write this list out. Hopefully you can break it down like I do here and do some stuff. Okay, but let me go back to that graphing calculator. I'm going to show you something that we use a lot in stats. And it's actually, go back to stat and go over to calculate. We actually, this is what we're going to be doing with my CAT students. We're going to be doing regressions, it's called. This is really the idea of math. The idea of math to graph something is from that graph to make predictions. It really is. Something has a quadratic situation that we can predict through that quadratic graph where it's going to end up in space. I mean, that's I showed you those things with orbits being elliptical or quadratic or whatever. But we're going to actually, with CAT students, use these regressions to find out what equation matches the data in a list of data. And there is something built in the calculator that shows that. But for you guys, and for stat classes, we would use 1 and 2 a lot. 1 variable stats and 2 variable stats. We'd also do some other stuff, but in this position, this is where we're looking. We're going to do 1 variable stats. Notice when I hit that, it asks which list did you put the list in. This is for higher end calculators. Lower end calculators, it just says 1 variable stats and you just press enter in the main screen. But we did put it in L1. You can put a list in L2, L3, L4. You just have to tell the calculator, I want the list L3's 1 variable stats. Very simple, right? And then look at what we have, and I should have put this up there. Darn it. That is the mean, X bar. And I did not do that last hour. I did say it, hey, I should put that up there. Mean actually does look like this, but we do that tomorrow, so I know we're fine. That is the symbol for mean, or average. Okay, so there that mean is. And then don't worry about those other things. You'll see what those are maybe later. But look at least one more thing. Median. And now I'm going to show that by hand how we end up getting that. Then I'll show you some other things that we have up here that we need for a box and whisker. So the mean was, what was that number again? 76.9 we'll put. Then I'll get this ready. 76.9. All right. So for this data that we have here, and then I did show some other things. I sorted, and then in the calculate feature, you can do mean and median. You just can't do mode. You have to do that by hand. So let's look at that and find that. It's probably in the, in here. Maybe not. Maybe it's in tests. I think it is in tests. Let's see. Maybe not. Maybe it's in math. Okay, that's funny. Yeah, it is in math. Wow, that's weird. So, no. Wow, this is embarrassing. I forgot where mean and median was. I'll have to find that later. That's funny. So I know 1 variable stats had it. That's funny. I cannot find it here. Calculate? It's not in calculate the mean. Tests? No, I knew that wasn't going to be it. That's funny. I'll have to look that up later. All right. Obviously, last year I found where those are, and I can't believe it's not in those 2 positions. One more time. All right. There's another. Not even in nums. Min, max. That's wild. Not even in probability. Hilarious. Okay, I'll look at that up later and find out where the mean and median buttons are. All right, cool. I'm glad that happens. Sometimes, we miss those things. You can see it right there, and I know I could go to my catalog and find it, but I wanted to find more specifically where we're at. Okay, now get ready for this. Here's what a box and whisker plot does. How many people have heard of a box and whisker, by the way? I think you did this back in the day. This is like a grade school little reminder. Tomorrow's not. All right, tomorrow gets into something really weird, standard deviation. All right, but box and whisker plot really cuts your data into quarters. It's really what it does. Organizes it. I'm just using sometimes I use non-math words, and it's okay. Cuts it into quarters, puts it in nice little quarters, 25, 50, 75, 100% of the data here. And that's what we're going to do. And you'd have this list written again down in the notes here below, but just use your numbers up here. Don't rewrite the list. Okay, first things first, don't forget range. Range is just how much of, what does this data cover? And it actually covers 68%. From 32 to 100 represents 68%. So it's just highest minus the lowest. All right. And then quartiles, quarters. That's what we're going to have to set this data up into. All right. And then that's why I have this written the way I do with some highlighting. So you take your list that you have up there, don't rewrite this, and do highlight these numbers. This number right here is the 12th and the 13th number. That's what I have highlighted in red. The problem with this is if I want the true median, the true middle, and I have 24 numbers, which is what I have here, I have 24 numbers, then the median is actually two numbers. Two numbers sit in the middle of this data, not one. So what is truly the median? It's actually the average of these two, and is a number that's not even on this list. And that happens sometimes. So this is the median, and you saw that on my calculator. The calculator did say that. I'm not going to go to it yet. I'm going to go to it when I calculate the quartile 1 and 3. Okay, and then here's what Q1 is, which I will write in blue. Q1 is the median of the first half. That's all it is. So that means Q3 is the median of the second half of the data. And I was going to put the fraction in half. Here's what you need to understand. When the actual median is found from two numbers, because we have an even list, then to find Q1, you must keep that 78 because those are 12 numbers. And then this is 12 numbers. I do have a perfect half and half scenario. All right. And with that being said, 1, 2, 3, 4, 5, yet again, two numbers sit in the middle for Q1 because I have 12 numbers, an even amount of numbers again. So I got to do it again. It's the average of these two represent Q1. So that is 68 and a half, and that's what Q1 is. All right. And then same thing happens here. What is this? 13, 14, 15, 16, 17, 18th, and 19th are in the middle. So yet again, it's an average of those two since I have 12 numbers on the second half. I don't know why I put a 6 there. It's 86. Divided by 2, which is 85.5, and then that's Q3. Okay, so we're going to do a box and whisker off of these things here. Before I continue, look at the calculator. I got to do it again. Let me see if I can just pull that up. One variable stats, enter. Oops, now why did I do that? Okay, quit, clear. Okay, then I'll hit it again. Stat, calculate, one variable stats. Okay, and then go down here and then look at those numbers. They actually exist there. Okay, median was 79.5, and then we had 68.5 and 85.5. All right, so it all matches up. One more thing that you probably will not remember and may not have been taught to you during this. The idea of outliers. All right, get ready to be, maybe upset with what I say here, but it is true. All right, definitely been some outliers this year. There's some outliers on that test data right there. There's some certain outliers when I get 100, 100, and then most of the data is packed, like right here, 68. All right, you just made a little mistakes here and there, and they added up. Not a catastrophe. But then I've had a ton of these, all right? And that's why as a teacher, we do have to look at that data and say that's an outlier. I got to worry about this because these are the ones that are going to calculus, and that's what this class is designed for. Do well in Math 3 honors so that you can get the calculus AB. And if you are an outlier, you either pick yourself up or this is not the class for you. And that is 100% true, and I've been that way since August. And I think I introduced the class in that way. And you may not have liked it, but it doesn't matter. This is the truth. So there is a way to calculate these mathematically to say with this data list and how this data is packed, these numbers do mathematically represent outliers. Nothing personal, it's a mathematical structure. So here's what it is. Interquartile range, first we have to find that, finding the difference between Q3 and Q1, and then there is a calculation to find outliers. But here's Q3 minus Q1. It's quite simply 85.5 minus 68.5. And I think last hour we got that to be 17. Okay, so that's the difference between Q3 and Q1. You're not done yet, though. Somebody came up with this multiplier. And I looked this up. This was in our Algebra 2 book, and then I made sure last year. Let me just double check. Let me make sure that this still holds true, that statisticians still have this multiplier as a way to find outliers in data. So take this 17, this interquartile range, and multiply it by that 1.5 multiplier. Some statistician came up with this, and everyone has accepted this as how we can calculate if we have outliers or not. And then I'm going to wait. I'm going to use this when I start making up my box and whisker to make sure and see if I have outliers or not. And then I must show it in my box and whisker. So I'm going to hold that data value for a second. And then unfortunately, I do have to do this. I have to see the list in order to make my box and whisker. And here's ultimately what you should do. And I do want to go this small. I want to use this whole page effectively so I can see that data all right. And hopefully you can too. You can see your own. All right. First, though, we really should draw a coordinate plane. Wrong. We should draw a number line is what I meant. So our grades could have went from 0 to 100. I could have started it at 30 or whatever, but I'm just going to go the whole full 0 to 100 thing. And then 50. And then this is 75, so I'm going to jump a little bit backwards for 70. This is 75. I'm going to jump a little forwards for 80. And then that should give me at least spacing that looks reasonable. 60. And then this is 25, so I'll jump a little forward for 30. 25, a little backwards for 20. Then I'll cut those in half. And then the spacing doesn't look too bad. Okay, 10, 20, 30, 40, 50, all the way to 100. Because your box and whiskers should be relative to, the possibilities of this set of grades if we put it in a percent. Okay, so the very first thing that you put is the median, which is 79.5. And what you do with that is make like a line like that, because we're going to make a box out of this, and I hopefully you remember this. Then notice it is right around that, that value there. So this is the median. This is 79.5. So again, statistics. This is why we're doing this grade school thing, organizing data. One way you can do this is a box and whisker plot. All right, Q3 is 85.5, pretty tight here. Oops, my computer moved. So this is Q3. I feel like I did this a lot nicer back in the day, but Q3 is 85.5. I could put this in blue, but I didn't. And then Q1 is all the way down to 68.5, a little bit more space. So approximately right around there. You can actually do this on the graphing calculator. It's just not really, it takes a long time. It's a lot of setup. It's really not that important that you copy the screen up. The calculator doesn't really do a lot for you there. Okay, so there's what we got. Now we got to stop. Okay, for outliers. Do I have outliers? We could have outliers on the high end, on the positive end. I could have somebody get 100 on the test. Then the next highest grade is a 68, 65, 63, 60, 50, 60. But, everyone else didn't do so well. So an outlier could be on the high end. This person probably should be in a higher math class. And then the test I should probably redo, and but this guy knows what they're doing, and the rest we need to kind of do a redo. So that could also happen. I notice I don't like that little sloppy side right there. It's going to drive me nuts. So here we go. Okay, so here's what we got to do. We go to, and I guess I got to put this off to the side, Q3's value, and you see, is there a high-end outlier? Is there a grade that is larger than 25.5 points compared to Q3? I already saw a head shake a no. Because what's 85.5 plus 25.5? 111. Did anyone score a 111 or higher than a 111? Yes or no? No. So on the high end, there is no outlier. On the low end, we take the Q1 value and subtract. We want to see, is there something worse than lower than 25.5 points compared to the Q1 value, where we're cutting the data into quarters. And in this case, there certainly is. I think we get a 43 on that. Are there grades that are lower than a 43, yes or no? The answer is yes. There's two of them. All right, so here's what you do, and this is why I had to calculate that first. Now I have to do my whiskers. But this lower end whisker stops at the last data point that is not an outlier, which is 55. And then what I have to do is show the outliers as their own separate dots off of the box and whisker. Right? And then quite honestly, fine, let's not talk about grades and tell students that they're outliers, although it is a problem, and I've never had more of a problem ever than this year. All right, the CAT class is really rough. There's a ton of outliers. But for regular data, that's how people make decisions, and the outliers, they kind of cast them out of the data. They make their decisions based off of the non-outliers of the data. That's actually true. Statistically, what happens. And then 100 is the end in the highest grade. So there's that whisker as well. Okay, so that's how you do a box and whisker. It's real simple. And what it's supposed to be able to do is cut the data into quarters. Okay, so really not hard stuff, but I did want to show the calculator because we have time. But then there's some little wrinkles we should be aware of. And then I'm going to go to percentiles. But do this data real quick. Do that data real quick, and don't use a graphing calculator. I just wanted to do this. I'm not doing a full box and whisker, but I want you to see the difference on this one. And the difference is, as you're writing this down, is there's 11 numbers. Okay, so I gave you an odd list. This is more than likely what's going to happen on the test. Smaller list, not going to be all crazy with the 24 numbers. All right, and then this is what you should do first. Here's the typed out test. Although you can see it's my chicken scratch writing. And when you put them in order, you select the smallest number first, then you destroy it. All right, so that you don't look at it again. But it's also a way to organize your thoughts and make sure you don't miss any numbers. And then it looks like the next number is 14 and 14. Make sure when you cross them off, you write them right away. And then what do we have next? It looks like 17. Move over a little bit for you here. And then I think it's two 19s, which is looking like that might be the mode. This is bimodal. You can have two modes. 19 and 17 both look like a mode here. And then you can see I probably wasn't very just like doing numbers here. 21. 20, oh, trimodal. My bad. I got two 23s. So you got three different modes. Do listen that I said that, all right? And then 24 and 25. Okay, so that doesn't take long. If you try to get your calculator and type them in and then do a sort, and then where's that button at? It's a big waste of time. That's why we won't do that much. Fumble. Okay, now here's the big problem, or not a big problem, the big difference. We got 11 numbers, 1, 2, 3, 4, 5. So it's actually the sixth number right on the dot that is right in the middle. So my median is 19. Okay, so that's not hard. That's not what I'm here for on this example. What is a wrinkle is this. When you find Q1, you ignore that 19 and don't use it. You need Q1 from just here to here and you stop. You do not use that definite middle number that's in the middle of the data. All right, and then it just so happens we get lucky again. 1, 2, 3, 4. There's 5 numbers, so Q1 is exactly a number. It's that 14. All right, so I don't have to do any averages. Same thing on this other end. You ignore that 19. 1, 2, 3, 4, 5. This is Q3. And then oddly enough, we found out that there were no outliers. 23 minus 14 is 9. And then when I took 1.5 times 9, I got 13.5. 14 minus 13.5 is 0.5. I thought for sure 1 would be an outlier in this data, but it ended up not being. So anyway, that's how you do a box and whisker on that. All right, and then I got to end with this. This is wild, weird, wacky stuff. And this one, I looked up a lot of stuff on this too, just to make sure. All the little semantics, all the little quick details. And I'll just tell you at the end what you actually need to do. All right? Hopefully in April, you're going to be taking a practice SAT. The juniors will be as well. And what we love is comparing our junior data to all the other schools. First of all, what did we average as a school? But then individually, they give you a ranking, honestly. And usually that ranking is a percentile. Where do you fall with the rest of the country? That's the idea. We all take the SAT at the same time throughout the whole country, the whole United States. And then the juniors are going to get what percentile are they compared to every other junior in the United States that took that SAT that day. I know there's a couple different dates, but at the end of all the dates being done, they do this. Where you really want to be is in the higher 50 percentile, 60, 70. And that's a chance with where you're at right now, being in an honors math class, I would think. But that's what that means. If you're the 60th percentile, you are actually above 60% of the rest of the country. You got it? Above. That's why I have this up here. What's the 64th percentile? The number that represents the number that is higher than 64% of the rest of the data. That's the definition of what a percentile is. When we're talking about all the juniors in the United States, we have millions and millions of numbers. I don't know what the actual number is, but I'm sure it's in the millions. So there's a whole bunch of data points, a heck of a lot more than these 24. All right, so that does present a problem when we have a small data list. But here's the rule. What you do to be the 64th percentile is you take 0.64 and you multiply it by the number of data points that you have. There are 24 data points here. All right, and I think when I did this, I'm going to use my calculator in my hand because you don't really have to show that to teach. That's the 15.36 number in the list. Does that make sense, first of all, yes or no? Is there a 15.36 number in the list? No. So now here's the weird part. What do? Do I round down or do I round up? And the answer is you got to go up. Because if you round down, you're actually going to a lesser number in the list. Therefore, you are not going to be above 64% of the numbers. You have to go up every single time on this stuff. So I must go to the 16th number in the list. All right, I got to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So for our purposes, 85 represents the 64th percentile. Now, it's not great. When we have a small list of numbers, it's not truly the 64th percentile. But I'm just giving you what you need to do in order to do this. All right, then I'll show you something else even later. All right, so let's just understand that rule. 20th percentile, well, same thing. 20% of 24 numbers, as long as they got the numbers in the list organized, 0.2 times 24 is 4.8. There is no such thing as a 4.8th number in the list. So I have to go to the fifth number. That's one way of doing it. 1, 2, 3, 4, 5, 66. Okay? All right. Let's think of this list and then really make sense out of it. Let's pretend we have a stupid list like this. Somebody got a 1 on a test, next person got a 2, next person got a 3. I think you know where this is going. This is the scores on a quiz. It aligned perfectly that everyone represented every single data point they possibly could. Okay, and then let's do the 20th percentile. Now again, with a lot of numbers, it works out a lot better. With a short list, the percentiles do not work out the best. But this is a good one. I like this. So the 20th percentile. By the way, how many numbers do I have in this list? It's very simple. How many? 10. What's the 20th percentile? What number in the list are we looking for? Well, the second, which is 2. Could that possibly be the 20th percentile? Is 20% of the data below 2? Yes or no? No. What percent of the data is below 2? What percent? 10%. This is my point why you can't pick the second number in the list, which is 2. So this is what I found out on the internet. The 20th percentile is actually 3, that number right there, or they make up a number 2.5, meaning if we did have that data point right there, if that was a data point, then yes, 20% of the data is below 2.5. Does that make sense? All right? You don't have to worry about that. You have to select 3, though. You cannot select 2. In all cases, you go to the next number in the list because 3, that number right there, also has 20% of the data below it, 1 and 2. Right? And that's what is really tricky about percentiles. So on the test, we're going to have this happen. You always, always, always round up. Always on percentiles. Because you got to make sure you satisfy that percentile. You got to satisfy that the data point you picked, that percent of the numbers at least are below that number. All right? This one's really weird. And I actually purposely came up with that one so that you understand what percentile means perfectly. Okay, anyway, I got a sheet for you. I'll hand that out to you real quick. Not too